Nobody tells you what each level of a software engineering career actually requires before you're already in it. The titles exist, the salaries exist, the honest description of what changes at each level and what it costs you does not. Here is every level, what it actually demands, and what nobody explains before you get there. Junior engineer. Every bootcamp and CS degree teaches you to build things from scratch. Your first job requires you to understand a code base someone else wrote over 5 years, across a team of 20 people, in a style you've never seen, using patterns you've never been taught. Your first 3 months are spent reading code, not writing it. This is the gap nobody warns you about. The distance between knowing how to build a feature and knowing how to navigate a system that already exists. The engineers who survive this level are not the ones who code fastest. They are the ones who ask better questions, read documentation carefully, and resist the instinct to rewrite things they don't yet understand. The junior who says, "I don't understand how this works, can you walk me through it?" grows faster than the junior who figures it out alone and breaks something in production. Mid-level engineer. Mid-level is where most engineers get stuck for years without realizing it. You can build features independently. You ship reliably. You don't need supervision for well-defined work. You are also still waiting to be told what to build. The difference between staying at mid-level and moving to senior is not technical skill. It is one specific capability, knowing what not to build. A mid-level engineer given a feature request builds the feature. A senior engineer asks whether the feature should exist before deciding how to build it. Most engineers at this level don't know they're stuck because the work feels increasingly comfortable. Comfort at this level is the signal that you've stopped growing. The engineers who move up are the ones who start making decisions before they're asked to. Senior engineer. Senior is not about writing better code than junior engineers. It is about making the engineers around you more effective. A senior engineer who makes 5 engineers 20% better creates more value than one who codes 10 times faster alone. This is the level where technical skill stops being the primary differentiator. The skills that matter most at senior level: communication, judgment, and the ability to take ambiguous problems and turn them into clear work that other people can execute. Senior engineers write documents. They run design reviews. They have opinions about processes and systems, not just implementations. The engineers who resist this shift, who want to stay heads down and write code, often plateau at senior for a long time. That is a legitimate choice, but it has a career consequence. The fork. After senior, 2 paths exist. Most engineers choose based on which title sounds more impressive. That is the wrong reason. The individual contributor path, staff, principal, distinguished engineer, requires you to have growing technical influence across larger and larger parts of the organization. The engineering management path requires you to genuinely prefer your team's success over your own technical achievement. Both pay similarly at top levels. Both are legitimate and respected. Choosing wrong costs 2 to 3 years before you realize the misfit and switch. The question that separates them is honest and uncomfortable. When your team ships something excellent that you barely touched, do you feel proud or do you feel left out? If proud, management might fit. If left out, stay on the IC track. Staff engineer. The level that didn't exist 15 years ago. Staff engineers solve problems that cross team boundaries. They don't own a code base. They own a technical direction across multiple teams simultaneously. In practice, roughly 60% of the work is writing documents, reviewing architectural proposals, and influencing decisions without direct authority. 40% is still coding, but the coding is usually proof of concept work to validate a direction, not production feature development. Companies like Google and Meta formalize this level because senior engineers were leaving for management roles they didn't actually want. The IC track needed somewhere to go. Staff gave exceptional technical contributors a path that didn't require them to stop doing technical work. Principal engineer. At principal level, your job is to be right about things that matter at company scale. Architectural decisions that affect every team. Technology choices that will cost or save millions of dollars over 5 years. System designs that will either scale to 10 times the traffic or require complete rewrites at the worst possible time. The specific skill that separates staff from principal is the ability to say, "We should not build this at all," and have leadership listen and change direction. This requires something rarer than technical depth, the credibility that comes from having been right about hard things, visibly, over years. Principal engineers are not louder than staff engineers. They are trusted differently. Distinguished engineer and fellow. The levels most engineers will never reach. Fewer than 0.1% of engineers reach distinguished or fellow level. At Google, the senior fellow title, the company's highest technical rank, is held by fewer than 10 people across the entire organization. These engineers define technical direction for industries, not just companies. Jeff Dean, one of the most cited examples, co-created MapReduce, the distributed computing framework that inspired Apache Hadoop and changed how large-scale data processing works across the entire industry, and co-designed Bigtable, the storage system that now processes more than 6 billion requests per second at peak and underlies dozens of Google products. Both technologies became the foundation of how the internet processes and stores data at scale. That is the scope of impact these levels represent. Not better code, not faster code. Technical decisions whose consequences are still running in production 20 years later. Engineering manager. When you move into engineering management, you stop being the expert in the room. Your calendar fills with meetings before you write a single line of code. Your performance is now measured entirely by your team's output, not your own. If your team ships poorly, you are responsible. If your team ships brilliantly, they get the credit and you get the satisfaction of having built the conditions for it. The engineers who thrive in management genuinely prefer that arrangement. They find more satisfaction in unblocking someone else's excellent work than in doing excellent work themselves. The engineers who struggle in management spend the first year grieving the technical depth they gave up and trying to stay involved in implementation decisions that are no longer theirs to make. Both responses are honest. Only one of them is compatible with being a good manager. VP of Engineering and CTO, where code ends. At VP level, most engineers write zero production code. The job is hiring decisions, organizational design, budget allocation, and translating business goals into a technical strategy that the engineering organization can execute. The distinction between VP engineering and CTO that most people get wrong. VP engineering manages people and execution. CTO manages technology vision and external relationships with investors, with partners, with the technical community. At many companies, both titles exist simultaneously and serve genuinely different functions. At smaller companies, one person holds both. Understanding which role you're being hired for and which one you actually want is the conversation most engineers forget to have before accepting the job. If you're trying to decide which of these roles to pursue, every tech job explained covers every tech career from the outside, including salary ranges and what the work actually looks like day to day. It's on screen right now.